as we
Yeah, and first of all, I forgot to record the meeting. That was a big mistake. So I have to ask everybody for their help, and that is at the beginning of our class, please remind me to record the class, which I forgot to do.
sure.
Okay.
Which I really wish I had done this time, because that's when I told everybody where everything was, and I knew that there would be people who didn't show up. Not that it was your fault, but I'm just saying I had a feeling there would be people that didn't show up. So I should have recorded it. But anyway, okay, so you're supposed to be here, so welcome. And we are currently looking at the book website, and we're looking at a video. And just to quickly tell you what the video is about. It's about anyway, and we'll have to show you the other stuff that we did later. But anyway, this video is about a study, a medical study about stents, S-T-E-N-T. Can you see that, S-T-E-N-T?
Yes, Professor.
Yeah, and those are things that people get put into their, I guess, their arteries or something, their veins, their blood vessels. It's the idea here is that it might prevent a stroke. And we are trying to determine whether we can talk about what we call a causal relationship. That is, that we can say, by looking at the results, can we determine that a stent did not, reduce the number of strokes. Anyway, we're studying this experiment. We talked about the details about how we can discuss this, but you missed that part. So anyway, that's where we are now. So we're just watching this video. So we're going to watch it.
Thank you, Professor.
Well,
Statistical data analysis allows us to consider all of the data at once. The table below summarizes the raw data in a more helpful way. For instance, to identify the number of patients in the treatment group who had a stroke within 30 days, we look on the left side of the table at the intersection of treatment and stroke. 33. We can compute summary statistics from the table. A summary statistic is a single number based on the sample that summarizes a large amount of data. For instance, the primary results of the study after 1 year could be described by two summary statistics: the proportions of people who had a stroke in the treatment and control groups. The proportion who had a stroke in the treatment or stent group was 45/224, or 20%. The proportion who had a stroke in the control group was 28/227, or 12%. These two summary statistics are useful in looking for differences in the groups, and we are in for a surprise. Comparing 20% to 12%, we see that an additional 8% of the patients in the treatment group had a stroke.
so remember, before I said, oh, it seems like it's unfair. Who gets, goes into which group, right? We flip a coin. We say, you go to the stent, you don't get the stent, right? And I was thinking, I didn't remember this video. I was thinking, the people that don't get the stent, they're the unfortunate ones, right? But actually, it turned out not to be true, right? Unfortunately, getting that stent was not such a great thing, according to the data.
This is important for two reasons. First, it is contrary to what doctors expected, which was that stents would reduce the rate of strokes. Second, it leads to a statistical question. Do the data show a real difference between the groups? Well, suppose you flip a coin 100 times. While the chance a coin lands heads in any given coin flip is 50%, we probably won't observe exactly 50 heads. This type of fluctuation is part of almost any type of data generating process. It is possible that the 8% difference in the stent study is due to this natural variation.
Okay, does everyone understand this statement? So yeah, we got 20 and we got 12, and it certainly seems like the stents were not a good idea. But there's some very statistical, probabilistic, random data generation that could be the reason why, just like, even though when you toss a coin, you should get heads half the time and tails the other half of the time. It's never going to work out exactly like that, right? There's some variation in the data. The same thing could be true for this 8%. That could be the reason why there's an 8% difference, just statistical variation. But that 8% is quite large, and so it's very unlikely that it's really due to that.
However, the larger the difference we observe for a particular sample size, the less believable it is that the difference is due to...
So suppose I told you I had a fair coin here, and I started to toss it, and I said, I'm going to toss it 1,000 times. And suppose I got 4,090. Suppose I tossed it 10,000 times, and the number of heads was 4990, and the number of tails was 5010. And I told you it's a fair coin. It's a balanced coin. Would you say, oh no, that doesn't seem right? Like, no, your coin is not balanced. Would you say that? No,
Yeah.
you wouldn't say that, right? It's not much difference, right? Only 20 out of 10,000, or even 10 out of 10,000 deviation from what we would say is exactly perfect, right? So you don't really expect, that I have to get exactly 5,000 heads, right? No, it's very unlikely I'm going to get exactly 5,000 heads. So this would not argue against it being fair. However, suppose this happened. And now would you say the coin is 50-50? You'd probably say, no, your coin is not 50-50, right? Right? Does everyone see what I'm talking about? Or even make it worse. Let's say 25 and 75. If this happened, you'd say, I don't think you have a 50-50 coin, right? You have some weird unbalanced coin, right? Do you understand? Okay, the same thing here in this video. If we only got the difference was, one was say 20% difference and the other was 19%, then we'd say, oh, that was just random. That was just due to random chance, and we can't say that the stent caused the stroke. But this argues that the stent does cause the stroke, right? So that's what she's talking about here.
Variation. However, the larger the difference we observe for a particular sample size, the less believable it is that the difference is due to chance. In this video, we learned about treatment and control groups. We were introduced to data tables and summary statistics, and we saw an interesting data set with a surprising story. If you learned something you found interesting, share this video with a friend, and visit openintro.org for more resources.
Okay, so that's a very interesting. Anyway, that has many important points and parts of it. So we saw what's called a controlled experiment. So a controlled experiment, we split things into control group and treatment group, and we randomly assign who goes into what group. Okay, and then we saw, that we had a long table and we summarized it with a different table. And then we also saw that we did some analysis by forming ratios, and we saw that the difference was in the opposite direction that we expected. And we also saw that the difference was fairly large and probably not due to just chance variation. Okay, so that it wasn't due to just chance variation. Okay, so that's a very good introduction. Now I thought we could just do a little bit of playing, but I will be asking you to do some homework in this textbook here. Where is it? Wherever it is, here. This textbook here. So that was the case study here, and then some more So they break this down into some important terms that we need in order to talk intelligently about data. And so we have that, and then we have next section is so how to collect data. So this is very important, especially for people who want to do some kind of study, some kind of statistical study. You need to know about how to collect data and what's the idea of the set of all the data, and then you collect a sample. You need to sort of think about what's the relationship of the sample to all the data, because really you're not trying to make, when you are doing a study and you collect a sample of data, you're really not interested in that sample per se. You're really trying to talk about all the data, but you only have a sample. But that doesn't mean that's really what you want to make conclusions about. You really want to make conclusions about the whole, what we call the whole population. So anyway, you need to think about those things. And so they go into these this discussion. So we will definitely cover this section and the next section and so on. Okay, so that's that. Now I thought we'd just have a little bit of play with this tool called RapidMiner, which I asked you to install, and I have it installed on mine. And this RapidMiner is very expensive, actually, but we have access as at an educational institution to a free version. Now, if you want to learn about data science, RapidMiner is one way to learn about it. And you can, if you work for an organization, they may have RapidMiner, and then you wouldn't have to pay for it. People who know this tool are well paid, extremely well paid. Anyway, we're just going to play with it. There are some tutorials that are built into it, and we're going to go through a little of that. So it takes a bit of time to open up. Now there are some other tools, as I said, we're also going to look at. So we're also going to look at something that I use in my class called Weka, which is not actually. Interesting history of Weka and RapidMiner is that Weka was made in New Zealand by a university professor, and he did it all open source. The whole thing was written in open source, which means anybody can use it, can modify it, can read the code, can understand all the algorithms and everything. And then this company, RapidMiner, went and took all of his work and made it into RapidMiner and selling it extremely expensively, like probably, $10,000 or more per year or something like that to have it. I don't know exactly what it costs, but anyway, so that's kind of the history of it. Okay, so this is when you open up RapidMiner, you'll see this. And of course, you don't know what the hell this is about, but you can see that there's something called Start, and there's something called Learn. Okay, and I want to go to Learn, but just to show you, they have sort of templates that you can use for churn modeling. Does anybody have any idea what that means? So that means that anybody have a mobile phone in Japan? I guess everybody does, right? So you have one of the, well, I don't know. It's just, maybe some of you have Docomo, right? Or maybe some of you have something else. But anyway, let's say Docomo. So Docomo, they're interested in trying to predict who's going to leave their, who's going to stop being one of their customers. Like you sign a contract, but then at the end of the contract, you go off and you say, no, I don't want to use Docomo anymore. I want to use somebody else, right? So they have an incentive to try and predict who's going to leave and who's not. And that's called churn, when people leave your when you leave your service. And so we model churn means we want to be able to predict who's going to leave and who's not. You know, if you know somebody's going to leave, you might make them a special offer or something like that to keep them to stay. Okay, direct marketing. They have another template for credit risk modeling, market basket analysis, predictive maintenance, many things. Okay, but anyway, let's go to the learn. So here we have some tutorial. So let's just see how RapidMiner works. Now, do I want to do it this way or do I want to show you a video that I made? I think it'll be more effective if I show you a video. So I'll do that. Just a second. Let me do that. So that is here. Put it here. Okay. Here. So let me just show you a video of those tutorials. Okay, so let's take a look at this. So the tutorial is over here on the left side. Okay, so let's do it. So when you're doing data science, again, for those of you who just showed up, who came late, there's a data science seminar this evening. You should have received an invitation for that from our Manaba site. And I am hoping and kind of expecting that everyone who can come will register and come. And I said I will give some extra credit for you to come because you can learn about what data science can do and maybe how it can help you in your career and in your academic career as well. Okay, so let's. Yes?
Professor already registered for that and placed relevant questions there as well.
Great, excellent. Thank you very much. Okay, let's take a look at this. What time is it now? 3:30. Okay, this is just a quick intro to RapidMiner by way of a few steps in their tutorial that comes as part of the application itself. So let's go to tutorials. And that brings this up, and you go to this tab here, or if it's not already there, and it gets started. And let's check this out. So this is retrieving data and then checking out the data. They call it operators and processes. So I guess we can say that at the same time that we retrieve data, we learn a little bit about what's meant by operators and processes. So I'll just not save any changes. So you get this. So they say we have a super brief intro to using RapidMiner on the left of your screen. So let's check it out. So that's over here. Maybe I'll make it a little bit bigger. RapidMiner Studio has a lot of features to offer. In the next few minutes, you'll learn how to use RapidMiner Studio to perform basic data science techniques such as accessing data, transforming it, and building a model. And down here in the explanation, they say, notice the dotted line preview in the process panel. So this is what they call the process panel. I guess this is what we call the repository. This means like where you access your data. And these are operators. This is what things that you want to do to the data. And over here they have something called parameters and help. And here is they say, notice the dotted line preview in the process panel. So they're talking about this dotted line here. So this is what we're going to build in this particular part of the tutorial. This shows you the process that you will be building in that tutorial. Okay, so RapidMiner, you do different steps, like you import the data, then you transform it in one way, and then maybe another way, and then you maybe add some more data to it or whatever you want to do, and then you do some prediction or something. Anyway, each thing that you do is represented by a little icon on in this so-called process panel. So you get like a sequence of steps. So you might have something here, and then something here, and then something here, and then something here, and then something. So you get like this sequence of steps. So that's the way it works in RapidMiner, which is a bit unusual, but not that unusual, because actually Weka designed this whole thing. Weka does it in many different ways. One way is to have this perspective, and they do have it this way, but RapidMiner only does it this way. So they kind of make this visual step-by-step. Anyway, you'll see what I mean in a minute. Okay, let's click here next. So let's start by retrieving some data about the Titanic passengers. So like many data tools, it comes with a bunch of free data sets, or it comes with a bunch of data sets that you can play with. So those in here in RapidMiner, they're going to be located somewhere in here in one of these folders. Okay, so you want to get the data. Now, if you don't have to use it, of course, you don't want to be stuck just using their data. You want to take your own data and put it in, and you can just import your own data, and then it'll be in here, and then you can use it just like you can use their sample data sets. So we want to, yes.
Is our imported data set has to be in a specific format to bring it on RapidMiner?
It depends. There are many formats that you can work with.
All right.
Okay? There are many formats that RapidMiner will work with because, as I said, it's expensive, so they're not going to leave you and expect you to do everything by yourself. Otherwise, you wouldn't pay for it. Okay. Find the repository panel on the left of the screen, so that's here. Open the folders samples and then data. Drag the Titanic training data set and drop it into the process panel in the middle of the screen. So they say go to the local repository, find the repository, open the samples. So let me close the local one actually and go to samples, and then data, and drag the Titanic training data set and drop it in this so-called process panel. So let's find it. Titanic training. So we'll learn the difference between what we mean by training and so on. But anyway, let's just bring that here. Let's see what happens. If you just put your mouse over it, you get a kind of display of what's actually in. Okay, so you can see when you just put the mouse over it, you can see a kind of a little bit of information about it. So you can see the name, the type, the range, and missing. So for example, missing, remember we're talking about a spreadsheet basically of data, right? A spreadsheet. So you might have like the name, and then the, what did we say? Stent, no stent, right? Remember we were talking about data. So maybe some, one column, this row is missing in that column. But so that's what missing means. But anyway, none of it is missing here. So the names of the variables in this case are age, passenger, sex, number of siblings. So everybody knows the story about the Titanic, right? So this is like whether people survived or not. And the task is going to be like, can we predict based on the other variables like their gender, how many siblings they had, were they first class, second class, third class, and so forth? Can we predict who was going to survive and who wasn't? That's the kind of thing we're aiming at in it. So I guess we could go and sort of scroll through it. And here, so this is like what's in the data set. Anyway, let's drag it like they said and put it here. Okay, so they say, good job, you have just added your first operator. So they call this like an operator. So operator basically means something that will do something. right? An operator does something. So we've got an operator. They call it the retrieve operator. And since it's called retrieve, we can take that as a hint that it's probably getting something or retrieving something, and it's probably going to retrieve the Titanic data. So in this case, it retrieves data from the repository. Now let's see what you can do with it. So let's click Next. Okay, so click Next, and so they say connect the output port. So that's, we don't know exactly what that means. The output port of this thing with the result port on the right side of the process panel. So here's the process panel, here's the right side. So this is the result port. So what they want us to do is connect this to here. So they say make the connection by either by dragging a line between the ports. So let's try that. So drag a line. I just clicked on that left one, and I'm going to drag it over to here, and then when it responds, I can let it go, and so it gives me this picture. So basically, what we're telling RapidMiner is that somehow we want to take our data and then look at it. So maybe instead we might have had a bunch of processes in between, but no, we're just saying we want to look at it now. Now I think I can put the mouse over it and just delete that and try it the other way. They say the other way is first click on one port and then on the other. So let's try that. Click on here. Well, I guess it's the same thing. And then there. Okay. So they call this some kind of process. So they say, excellent. So what does all these terminology mean? I guess they when they want to divide up all the steps in a, when you have a data mining task, you have to do a bunch of things. So they call each step maybe a process. So they said, excellent, you have built your first process in RapidMiner Studio. You can now look at the output of the retrieve operator. So we have this so-called retrieve operator. It's not really clear what that means, but anyway, we have it, and we can look at the output because we dragged it over to here, which means we can see what comes out of it over here probably. They say whenever you want to see the output of an operator, make sure it's connected to the res port. Okay, here. And the res port is the result port. Now, I don't know why they have to use res. It's only 3 extra letters just to write out result, which would make it sort of easier to understand. For some reason, they thought they have to simplify it to res. Okay, but anyway, it's the result port. Let's click Next. Okay, so now they say we can see the results of this by clicking the Run button. So that's up here. So I'll click it. Okay. So all this did was show us what was in the data. So all of that was just to show what was in the data. But this is just kind of getting used to this interface. I mean, we could have just opened up, for example, Microsoft Excel, and we would have seen something like this. So kind of simpler. But anyway, this is different than Microsoft Excel, and we're just getting used to it. So now we can see that this is like Microsoft Excel data file or a spreadsheet, and we have a bunch of columns. So we have the age of the passengers. Each row here is a passenger. And we have, did they survive in the Titanic or not? And what's their gender? And how many brothers or sisters? How many parents were with them? And what's this thing here? Passenger, what is that? No, I can't see it. I don't know, I can't see it. Okay, so something about passenger. So they say, nice, you have run your first process in RapidMiner Studio. When you click the run operators, when you click run, the operators in your process will perform their actions. RapidMiner executes the process and shows that there's not much of a process involved in that last thing, but anyway, and shows the data connected to the result port. So it shows whatever you connected to that result port. The center of the results view, in the center of the results view, you can see our raw data about the Titanic. So this is the center, about the Titanic passengers, such as family, size, age. On the statistics tab, we get a statistics summary, which provides useful information. For example, how many survived, and for example, suppose you want to know the average age here. Well, if this was Excel, you could do that pretty easily. Usually there's like a button up at the top here in Excel, and you can just get the average. Or you want to get the count of males and females. That takes a little more work in Excel. Let's try doing what they said, which is clicking this thing. They said the statistics tab. So here's the statistics tab. Okay, so the sex here, these are the counts. There were 322 female and that many male. The average age, no, not the average age, it's the minimum age and the maximum age. What else? Can we do anything else here? I guess we get a picture of it like that, which is nice. And we could click on open visualization. Let's just try that. It's a pretty good chart. So anyway, that one good thing about RapidMiner is it does give you very good charts. Okay, now how do I close this? Probably here. No. Okay, I closed too much. So let me go back. Now, if you want to go back, you didn't notice that we were in the results pane, but you can go back to here, and that shows you this process pane. So going back here is the results, going back here is the process. Let's try that again. Let's run it again. Okay, so we have the same thing again. If we click on statistics, we can see age like that, survive like that. I guess we don't get the average age automatically. I'm sure there's a way to do it. Let's click this and see what happens here. Okay.
You can.
Okay. So let's go back to design. Somebody say something?
I mean, the average age, you can just scroll the screen from left to right, and then it will show you in the results page.
Where do you go?
The result page. So you just scroll from left to right, and then you will see the average age.
Okay, thank you. Okay, thank you. And we're back here. Okay, and let's go to the next step. Congratulations, halfway there. Well done, you've just mastered your first tutorial. To quickly review, what did we do? Operators perform individual actions. You can connect operators together to build a process. So we'll see that we can do many operators in here. See the output of an operator. When you see the output of this, you connect it here. Running the process performs all the operators and automatically shows the results. Okay, let's go on to the next tutorial. Okay, let's do some data science. In the last tutorial, we loaded a data set and ran a process. We found out that this many passengers survived. Actually, I didn't check that, but let's build a process to see if those survivors have something in common or not. So a little bit of data science here, trying to figure out if there's anything about the people that, and trying to understand the data and see if there's anything that these people who survived have in common. Okay, let's click next. Drag the Titanic training data from samples. We're going to do the same thing again. Drag this onto here, anywhere. You've defined the first operation of your process. Now we learn how easy it is to build a machine learning model on this data, okay? So we're going to study in our class about decision trees, but we're going to use one here. Decision trees are a popular statistical modeling technique that finds hidden patterns in the data. Let's build one. Find the operators on the left. Okay, here. Open the folder called Modeling Predictive. Where is that? I guess it's here. It doesn't say Modeling Predictive, but supposed to be modeling, comma, predictive. Oh, sorry, modeling, predictive, and finally trees. Okay, so let's try that. Modeling, predictive, and trees. Okay. Drag the decision tree operator and drop it after the retrieve Titanic training. Let's move that over. Decision tree, not decision stump. Here's decision tree. Which one? Oh, sorry, here's one.
Yeah,
and drag that here. Okay. Now you don't have to put it there, but it makes it easier if you do that, I guess. Certainly makes it visually easier. Okay. Good, now we have the operator in the process, but we still need to connect so this is the idea. You take one of these and connect it to another one. So basically it means we're going to do something here and then basically take the output of that and do something. Okay, anyway, so this is a beginning of RapidMiner, and you could get very complicated processes here, and they have somewhere up here somewhere they have a bunch of templates that you can use, but you don't. I don't know if you'd usually use a template, or you might start with the template and then modify it in some way. Anyway, so that is a brief introduction to RapidMiner, which we haven't seen any real data science in it yet, but you just saw how to open it up and how to run a simple process and so on. Okay, so we may work with this a bit. Mainly we're going to work with the textbook, and we may do a little bit with this, and we will do some with R and maybe something with Weka, but we only have a short amount of time, so we can't do that much. Okay, so just as I said, I'd like to see you at this evening to hear about data science, and then I will be on the lookout for homework assignment, which I will give you regarding probably just the book. And as you know, the book is, you can pay what you want for the book, but you should get a copy of the book. Okay, does anybody have any questions?
Professor, can we have the video in Manaba or somewhere? It might be helpful.
This one here?
Yeah, this video here.
Yeah, I'll put that in Manaba. And also I will put this video of our class, but I only started recording when everybody showed up, unfortunately.
Thank you, Professor.
But I'll also put that there.
Professor,
Yeah.
I'm having a problem with installing RapidMiner in my MacBook. So could you please help me from where I can get help to install it?
I would look, of course, on the RapidMiner site. They should have, or if you're getting a particular error message or something. I mean, it definitely works on, on MacBook, on Apple. That's half the world's market. They're not going to mess that up. But if you get a particular error message, of course, you can look it up. You can Google it. But it should work. Or you can go to the help sections like a forum of RapidMiner's website, but I don't think you're going to need to go that far. It should be pretty easy to get it set up. Okay?
Okay, Professor, I'll dig it more. Thank you.
Yeah. Anybody else?
Professor, are we using same ID for this class for our next class? Because there seems two types of IDs going on for this Zoom.
I'm sorry, I don't follow your question. Can you say that again?
There are two IDs for this Zoom meeting, and are we using the ID we used for this class for our next class?
Yes, yes. So everything is with so the first 7 meetings, including today is one of the first, are with me, and then the next 7 are with Professor Gunarto. So just, for the first 7 meetings, come to this meeting. And then Professor Gunarto doesn't teach now.
Okay, thank you, Professor.
Anybody else? Okay, thank you. And I will put a few notes up on Manaba.
Okay.
Okay, thank you.
Thank you, Professor.
Thank you.
Please,
Thank you,
please,
Bye.
please make sure that you keep, check your email
Thank you,
for
sir.
assignments in Manaba.
Okay.
Will do.
Okay.
Will do.
Thank you, Professor.
Welcome.